Okay, I wanted to talk about the irrationality of modern physics. And this time I wrote up some stuff to read, so maybe I can move through this more quickly or more coherently, or not take up a bunch of time like I did last time, like an hour and 20 minutes. So, okay, I'm going to reiterate some of the things I said in the last video, but really I want to talk mostly about the irrationality of modern physics. Okay, so object and existence are the two most important terms in science. An object in existence must be defined such that there is only a single possible interpretation for these terms in order to avoid the theorists using a fallacy of ambiguity and surreptitiously switching between meanings throughout the presentation or dissertation. In other words, when they use the terms object and existence, there should be no confusion about specifically how they are defining and using these terms. They can't leave it up to their audience to decide for them what their own key terms say that make or break their theory with respect to their own theory. It's their theory, right? So they need to define their key terms and not leave it up to the audience to interpret them for them. In other words, the definition should narrow the usage of the term to where there's only a single possible interpretation, to where there aren't multiple possible interpretations, because otherwise you have what is basically the same thing as religion and church, where they certainly don't define terms like object and existence scientifically. They can't. They don't define these key terms. And then everybody takes away their own interpretation. They talk about truth. They talk about proof. They talk about all these things. They kind of skip over the whole giving a scientific definition for your key terms. And unfortunately, they're doing the same thing in modern physics. Okay, so object in existence cannot possibly be defined through empirical means because the definitions, which are part of the assumptions, are necessary to interpret and understand the empirical evidence itself. In other words, empirical evidence, we're talking observations, measurements, experiments, equations, all of these things that involve interactions, measurements, experiments, observations where my sensory organs are interacting and I'm observing, measuring, whatever you want to call it, all of these interactions, all of these empirical interactions, there's no way to even begin to understand what's going on, what they are, until we say, okay, let us assume that such and such objects exist, they're behaving like this, and that's what explains how the eye works, that's what explains how this instrument works, how this magnetometer works, how the Large Hadron Collider detector works, how any of this stuff works, how electricity flows through a wire, quote unquote, how the apple falls towards the earth. Anything empirically needs to be interpreted using assumptions about reality, what exists, how it's behaving. And that cannot be gotten through empirical means. So all empirical means of measurement being a comparison between a unit of measurement and that which is being measured, or it's a dimensionless quantity which is being gleaned through some kind of process, a measurement process or experiment process. All empirical and experimentation, all of these things involve the use of objects which interact with their environment, just like every other object in the universe. Even the lone dust particle floating in interstellar space is interacting gravitationally with its environment. So these measurement and detection and all these other instruments and sensory organs are no different. Whether it's our sensory organs, or scientific instruments at work, these objects interact with their environment in order to gain some kind of clues about nature. Typically, we're trying to arrive at a quantity, right, measurement. But we cannot possibly know the nature of that interaction because all our means of interacting with the world is through the use of sensory organs or instruments, wherein we don't know a priori how they are interacting with the environment. We don't have a first point of knowledge. We're always operating on this level where we're getting evidence, right? We're getting, if nothing else, sensory organs are feeding into the brain, causing all this neural interaction, or we're talking about instruments, detectors, whatever. Right? We have all this empirical interaction, but we have no first point of going, oh, we know now exactly how this interacts with reality. We don't know because all that interaction has always, our entire lives, been based on this empirical, sensory-based, instrument-based modes of interaction. So, it is impossible, through any conceivable empirical means, to get an unfiltered and full picture of what is happening in reality, since all clues are gleaned through empirical interactions via sensory organs or instruments where we don't know a priori what's happening in reality. Right. So, an example. I used a lot of examples last time. I talked about the eye, which not only filters for specifically electromagnetic interaction, the retina, but specifically this narrow band of the electromagnetic spectrum, the visible spectrum. Right? Then it converts that electrochemical motion in the optic nerve, and then neural interaction in the visual cortex, and so on and so forth. So it's filtering that interaction, and it's translating it, in this case, multiple times, into different physical contexts. We don't have the original what happened. We just have clues about it on down the line. And all the modes of interaction, they all operate this way because it's all empirical-based interaction. It's all an object interacting with its environment. It's filtering. We don't know what the interaction is. The only way to try to get at it is by making assumptions. And another example would be atoms. Sometimes I'll propose a different structure of the atom. And somebody will come along and say, no, we can disprove that. Look, they have pictures of the atoms. Aha, pictures. Oh, I mean, first of all, it's not a picture. Okay? Even if it was a picture, even your camera is kind of doing something similar to your eyes in terms of it's filtering for specific wavelengths of light. You're not taking a picture of X-rays. It's not with the normal camera. So there's always, it's an object interacting with its environment. There's a way that it filters. There's what it captures, the interaction. It is designed to gather, capture. So it's always filtered. It's impossible. When you think about it, it is impossible empirically to get at reality. We don't. I mean, we can only just interact and then try to make assumptions about that interaction. Okay. So for the atoms, pictures of atoms are not pictures, but they're an interaction. In a scanning, say, tunneling microscope, you have a metal tip with a, quote, voltage that is just an object, has a certain design, and it's interacting with its environment in a certain way, and that is producing an output, and that output is processed, and it comes out, say, as an image. Now, of course, that image certainly provides interesting clues about what happened in that interaction that produced this output that many times looks like this high detailed resolution image. We're talking about an atom, though. You're not getting an image, an unfiltered, naked picture of reality of what an atom, the structure of an atom is. You're getting it filtered through this, metal tip voltage, quote unquote, interaction that produces this output. Right? It's always that way. You never get the unfiltered picture. So I think that's pretty important to keep in mind. In terms of structure, that is something that is hypothesized and is not open to empirical confirmation or disconfirmation. Okay. So, every single variable and every single equation of physics represents a measurable quantity, which means that all variables represent a measurement process or experimental process of some kind which arrives at a number. Therefore, mathematics is purely empirical and evidence-based. It is impossible for equations of physics to specify anything directly about objects in existence. Objects in existence are qualitative. Mathematics is quantitative. Objects in existence are observer-independent. Mathematics is observer-dependent. Objects in existence are based on assumptions, whereas mathematics is gleaned through measurement and pattern recognition. Since all variables are based on empirical measurement, all equations necessitate the concept of observers, i.e., a sensory organ or scientific instrument interacting with its environment in some way such that something like a quantity can be obtained via the interaction, typically. If we're talking at least in the context of mathematics, mathematical equations. An object is that with shape. I gave this definition in the last video. An object is that with shape. What makes it scientific is that it can be used consistently in a scientific dissertation. When I say object, no confusion about what I'm talking about. And if there is, we can elucidate, elaborate, and it should be made very, very, very clear so there's no confusion. An existence is objects having location or shape plus location. Something has shape and location whether or not there are any observers around to sense it, measure it, detect it, or interact with it in any way. It has nothing to do with empiricism, right? The moon has shape, has a structure, and it has a location. Whether or not there's anybody there to see it, whether or not there's anybody there to measure it, but prior to the evolution of life on Earth, right, these are observer-independent qualities that do not depend at all on observers, and that cannot be specified directly by any observer-based methods or means, i.e. empirical means. It can only be established through assumptions. So, science is conceptual, whereas engineering and technology are empirical. Science is the body of rational explanations for consummated events in reality, and these explanations are based on assumptions which are nothing more than statements which are temporarily taken at face value for the purpose of understanding a theory. And that's very important because people get tripped up on the definitions or on the assumptions about what exists, and they say, but how do you know? How do you know that's true or false? Right? True, false, right, wrong, believe, disbelieve, accept, reject, blah, 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 blah. All of these very empirically based, verification, confirmation based approaches. But an assumption is not based on any of that. An assumption is simply, let us suppose, hypothetically, that this is the case, that this is what exists. Right? In order to simply understand a possible explanation. Engineering and technology are developed primarily through trial and error, and of course through the use of empirical mathematical equations which represent how measurable quantities vary with respect to one another. Getting technology to work in no way means that engineers understand the underlying physical phenomena at their most fundamental level. They routinely use conceptual analogs which are useful enough to get the job done, but which do not necessitate that they actually understand any physical mechanisms in a rational manner. For example, I can build a motor using magnets, right? Simple motor, thing just turns, okay, right? And I can just mess around with the magnets enough until I figure out how to get this little motor to turn. Does that suddenly necessitate or mean that I understand magnetism? How magnetism works? No, this is an empirical process. I trialed and errored it until I got the shit to work. Doesn't mean I have any idea how it actually works at a fundamental level, the underlying physical mechanism. All technology is this way. Doesn't matter if I do 10 million experiments with electrical wires and magnetism, and I derive Ohm's law and all these idealized mathematical relationships and all these other things. It's all experience based, all based on observers, and through enough trial and error, enough effort, enough investment, yeah, we can develop some pretty sweet technology. And it's awesome, and it's an incredible accomplishment, and it massively benefits the quality of human life. So, of course, I think it's a wonderful thing, but I think it needs to be kept in its proper context. People say science works. It's supposed to be this end-all be-all statement. Science works. Fuck you, right? Well, just because, no. Science doesn't work. Science isn't a thing that does stuff. Right? Engineering and technology, they work. And that's at least partially due to the equations and the fact that they can make accurate predictions, that they are useful, and also the trial and error. So engineering and mathematics and technology, all these things work. But science is purely conceptual. So rational science isn't necessarily useful or not useful. That's always the question. Is it useful? Why would I want to understand how things work? How does it improve my life? How do I develop a new technology using it? What's the point? Well, the point is kind of up to you, right? Is understanding useful to you? Well, I don't know. You tell me, right? Whether it's useful or not, it's subjective. It's up to the individual. I find it useful. Why? Because I like understanding things. To me, that is satisfying. And I think there are many people out there who are curious and want to understand nature and how things work. In fact, I think there are many people, many people out there like that. So in a way, of course it's useful. but just maybe not for technology. So rational science, all it is simply a formal means of steps required to propose a rational explanation. So science has nothing whatsoever to do with belief, truth, proof, knowledge, fact, or any other subjective concept which relies on an empirical observer insofar as they are supposed to relate to the natural sciences. Excuse me. Science is simply about proposing possible explanations for consummated events, and the purpose is to establish understanding, not the truth, not the proof. Right? It's just suppositions, hypotheses, theories, and understanding. The point is to enlighten through demystification, to understand how Mother Nature does her seeming magic tricks. An explanation has to be able to be understood before one can even begin to ponder whether we believe it, accept or reject it, think it's true or false, think it's proven or disproven, etc. Notice how if sometimes you disagree with academia, they'll say, you're a denialist. You're denying science. You're denying the gospel. Well, guess what? Science has absolutely fucking nothing to do with acceptance or denial. That's religion. Okay? Right? Science is about understanding explanations for consummated events. If the supposed explanation itself cannot even be understood because it is meaningless or full of unintelligible gibberish, then it's also meaningless to talk about whether one believes it or thinks it's true. If all you're saying is gobbledygook, doesn't even mean anything, then how does it make sense to turn around and go, I believe that, or I believe that with all my heart? Believe what? What? What's the theory? What? We haven't established understanding of what we're even talking about yet. Right? So every religion known to man fails to scientifically define key terms like object and existence, and then they proceed to ponder whether they believe their irrational, unintelligible, incoherent theories, whether they believe them, whether they're proven, whether they've used some empirical means, like they slap you on the head and say, the power of Christ compels you, right? You feel the jolt. Oh, I feel the Lord. Okay, not to make fun of religion too much. It's fine. I'm not a religious person, but it's okay as long as you don't, force it on anybody else. But, they do kind of the same thing in mathematical physics because they're using proof, empiricism, to try to prove and convince the audience of their irrational assumptions. So, on the subject of assumptions, we must and we will make assumptions about reality. The only choice is whether they will be rational or irrational, i.e. whether the key terms can be used consistently. So in order for an explanation to be rational, so to call it rational science, rational this, rational that, probably communicate what the hell rational means at some point. Kind of important. Alright. Well, I think there's 4 requirements for a theory to be rational. Number 1, do the objects have shape? In other words, can you present exhibits, either 3D models or illustrations of the objects of your theory? If the only inherent quality of an object is its shape or structure or form, then it can be communicated, established, communicated, hypothesized by simply drawing a fucking picture. You draw a picture, you say, that's what I'm talking about. This is the object I'm saying to exist. Now, there may be some limitations in terms of, hey, I can't draw every particle. I can't draw every... there's too many things going. It's too complicated. Okay, but it's okay to simplify a little bit. But you should be able to provide an illustration. And the most black and white question is, do the objects have shape, and do they have anything over and above shape? How are you defining objects? Just that with shape, either the objects have shape or they don't. If they do, well, good. You should be able to provide at least a simplified illustration of the object. So number 1 is the exhibits. I should be able to visualize, or if I'm blind, I should at least be able to feel the 3D model and be able to engage in the spatial reasoning to understand the description of what the shape of this object is, to grasp it. Number 2, definitions for key terms. As I stated in the last video, right? Single interpretation. How do you ensure single interpretation? Well, it's got to be non-contradictory. It's got to be non-circular. It's got to be non-synonymous. Those three things play right into the whole narrow it down to a single interpretation. But that interpretation thing, that's really the core of it. If you have multiple possible interpretations, in other words, if I define a term, it should be able to unequivocally, in a black and white manner, determine, through the application of that definition, whether or not something qualifies in a black and white manner in every conceivable scenario or example that somebody can bring up, right? Bring up an example. Does it qualify as motion? Well, does it have objects changing locations? Something like that, right? You should be able to easily qualify whether, yes, this example has that we're using that concept to understand it. Right? Definitions are about defining concepts, whereas the exhibits are about describing or illustrating the objects. An object simply has shape. You point to it, you name it, you say that's the object. That's its essence, form, architecture. The definitions are concepts, and a concept, which is actually very important, is a relation between objects at the first sort of level of concepts, or it could be a relation between concepts as well. Relation between concepts is an abstract concept. And you can have relations between abstract concepts. Humans can very abstract thinkers. And I think it's because we are such abstract thinkers that we start confusing our own abstract concepts like energy and all these other things and confusing them for real objects. That's really what the fallacy of reification is all about. So, on the definitions, narrow it down to single interpretation. Quickly, some examples. Non-contradictory, well, so you can't have a square circle, right? Those are two concepts that contradict one another. Can't have a square circle. It's inconceivable. How about non-circular? Right? I can't have a word here that I'm defining here with a word here that I'm defining here using that term. Did that make any sense? I'll give you an example. Okay, so line and point. If I define a line as a row of points, and I define a point as an intersection of two lines, I've used point to define line and line to define point. They're pointing at each other, and that doesn't narrow down to a single interpretation, right? Because you have the circularity. And like the contradictory, because you can't actually conceive of it, again, leaves it open to interpretation. Non-synonymous, as I used the example in the last video. Existence equals to be. Well, that's like saying x equals y. It doesn't narrow down what is meant by either term. It just says they mean the same thing, but doesn't tell us what they mean. It doesn't specify it. So it still leaves it open to broad interpretation. Synonyms are not definitions. And unambiguous, which is another way of really saying, getting down to that single interpretation. And at that point, when we think we have that scientific definition, I can say, aha, here's my scientific definition. And other people can come in and say, what about this example? What about that example? They can try to provide counterexamples that insert ambiguity into the interpretation or application of that definition and see if they can break it down in some way. But if it stands the test of rational discussion, then you might be onto something pretty solid. Okay. So, number one, exhibits. Illustrations. Number two, definitions for the key terms, which are concepts, relations between objects or other concepts. Number three, the movie. Last time I said that the hypothesis was the freeze frame. If the rational scientific method is a movie, the hypothesis is static. It's one still image. It's the freeze frame. It's the first frame of the movie. It's what objects exist and how they are spatially related to one another. And it's the definitions of the key terms. And the rest of the movie reel is part of the theory. It's, okay, then what happened? Or how did it happen? And now, okay, it may be a little difficult to produce an animation every freaking time you want to talk about a theory. So I'm not saying here that you have to have an animation of the movie. More like, okay, yeah, we can get away with verbal description or whatever. That's probably fine. But in principle, you should at least be able to provide, in principle, a illustration or a animation of the behavior, the dynamic behavior of the objects that you introduced in the exhibits. And the rational requirement here is that you can't have missing clips from key processes. And I'll give you an example. Let's talk about, say, something coming from nothing. Okay? Let's see if I can pull up Stephen Hawking's quote. If I can find where the hell that was. Okay, yeah, here we go. Stephen Hawking. Because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing. Why the universe exists, why we exist. It's not necessary to invoke God to light the blue touch paper and set the universe going. And everybody's like, oh my God, he's an atheist. Okay, so, alright, so creation, what's wrong with, he said spontaneous creation, or just something coming from nothing. What's wrong with that? Well, the third requirement, you fail on the third requirement. You may be able to get the frame in the movie where it's just a blank screen, right? There's nothing. Then you get the frame of the movie where there's an object there all of a sudden. Physical object with shape. But what we can't get is all the clips in the middle there where nothing is busy acquiring length, width, and height from the void, from nothing, and acquiring shape. Because, as I stated in the past video, shape and space are, number one, conceptual opposites. They are in contrast to one another. In fact, space is a strange, oddball concept in that it's the only concept that can only be defined in the negative by saying what it is not. It is the opposite of space. It's in contrast to shape. I mean, it's shapelessness, formlessness, nothingness, the void, emptiness. But anyway, you got nothing busy converting into something. Well, I can't show you the frames of the movie. That's a key process, right? That's a key process of my theory. I'm talking about something coming from nothing. So in order to understand it, in order to say, this is an explanation, this makes sense, I should be able to show what is happening in those missing frames of the movie where space, nothing, the void, is busy somehow converting into shape. And that's not possible, of course, because it's something either has shape or it doesn't. There's no partial shape, blending of shape and space. There's no mixing in between. Right? There's no conceivable in between. So it's impossible to show those frames in the movie. And therefore it's impossible to understand how something comes from nothing, and there's no possible way to explain it rationally. So that automatically disqualifies something coming from nothing. Any theory that says that. Now, Big Bang, does it say it? Well, if you say Big Bang says something comes from nothing, they'll say you're straw manning. Sometimes it does, sometimes it doesn't. But insofar as it does, it's irrational. And also, there's other problems, like the warp space-time. Anyway, so, you got the three things now. Exhibits, got to illustrate the objects. Definitions for key terms, which are concepts. Relation between objects or concepts. Right? They have to be able to be used consistently. Single interpretation, everybody understands the same thing. No church, no walking away with different interpretations. Third requirement is no missing frames of the movie. You got to be able to show all the key processes which are mentioned within the theory, the dynamics. Right? You can't be hiding things from us, all right, or else we don't understand it works. Kind of like, let's say, also intelligent design, right? Oh, we can't understand how, all these things would evolve, but there's some unseen mechanism that magically makes it happen. Well, that doesn't actually explain anything. Right? We don't need to disprove it or run an experiment. It just doesn't explain anything. It doesn't enlighten us as a mechanism. It's irrational. Okay, and the fourth requirement, this one's a little more subtle. We should be able to explain the behavior in terms of the form of the objects, such that we can understand the behavior in terms of the form of the objects. So as part of the theory, you're just saying, here's how the objects behave. But you're also going into the causes, the mechanisms and the causes, and saying, here's why the objects behave the way that they did. This tugged on this over here, and this pulled on this, and then that bumped into that, whatever it is. Right? Explaining causes. Start talking about causes. Then you're entering the domain of explanation. And it's based on all these prior assumptions. So, an example of that, for some reason, flat Earth comes up. Right? Flat Earth. Great theory. So you got, let's say, I think they say that the sun moves in circles above the disk. Sun moves in circles above the disk. Why does the sun move in circles above the disk? The Earth disk. kind of a basic question. Nobody really seems to ask it. They kind of just accept it. Okay, that's what the theory says, and oh, but I got this problem and that problem. But it's like, well, wait a minute. I mean, if we're just going to accept unexplained motion as part of a theory, well, then why even bother, say, trying to understand gravity? Right? I mean, hey, things just attract towards the Earth. We don't know why it happens. We don't have an explanation. That's just what it does. Right? It's taken as a given. We don't look for a deeper physical explanation for things that we can't understand. In that case, if you don't have that requirement. So, flat Earth, hey, well, why is the sun going in circles? What explains this motion? Right? And maybe they do have some attempted explanation, but that just gives you the gist of what that fourth requirement means. So, okay. Exhibits, illustrations, definitions for key terms, no missing frames, and explain the behavior from the form. Those are the four requirements of a rational theory, rational explanation. So, continue on. There are no objects. And this is getting into modern physics and the irrationality of modern physics. There are no objects anywhere in modern physics, and they have never been scientifically, there are no objects anywhere in modern physics, and they have never scientifically defined the terms object or existence, because doing so would obliterate every single one of their theoretical explanations. Everything is based on the fallacy of reification, where space-time, zero-dimensional particles, black holes, singularities, wormholes, Big Bang theory, gravitational waves, higher dimensions, energy, force, field, etc., etc., etc. All of these are nothing more than abstract mathematical concepts with no shape or structure. They cannot be illustrated, they cannot be visualized, and therefore it is impossible to imagine any explanation which involves these alleged entities, because what is an explanation besides saying what exists, what it did, its interaction, and the explanation for that behavior? Well, if you don't have objects, you have no interaction, and you have no explanation. Right? Physicists routinely use terms which strongly imply that they are talking about objects with shape, like warp, bend, stretch, curve, expand, vibrate, excitation, wave, disturbance, etc., etc., etc. Yet these are nothing more than empty metaphors, because there is no physical context whatsoever. There is no physical context whatsoever. The equations are purely empirical and based on quantitative measurements. They say nothing whatsoever directly about objects in existence, which are qualitative, and these objects in existence cannot possibly be proposed by anything other than assumptions. Abstract mathematical concepts have no shape. They cannot be illustrated. And every single illustration or animation anywhere in modern physics, like, say, the gravity well, the warping of space, warping, like it's a frisbee, right? Every single illustration or animation anywhere in modern physics is nothing more than a figurative illustration of an abstract mathematical concept which they are not alleging or assuming exists, and which is not meant to be taken literally. They are not meant to be taken literally. They are not literal representations of anything which is assumed to exist. They simply give the impression via illustrations and the terms used in their, quote, explanations or non-explanations, that they're talking about physical objects and the behavior of physical objects when they are not. There isn't a single rational explanation anywhere in modern physics. It's all based on abstract mathematical concepts, which is based on observers, which is based on empiricism, which says nothing and cannot say anything directly about objects or existence. Science depends upon making assumptions which are meant to be taken literally. Their assumptions are never meant to be taken literally. They are doing nothing more than poetry on the physical explanation side of things. And because they refuse to specify the objects of their theory or to scientifically define object or existence, they can cover all of their bases with a multitude of different and conflicting physical interpretations like waves, particles, fields, space-time, etc. And whenever anyone criticizes that person, and when anyone criticizes that, the person is always perpetually accused of straw manning. You're always straw manning no matter what. I'm always accused of straw manning, even if I repeat verbatim what a well-respected physicist says in their own words, because any and all criticisms are deflected by means of their constant use of a fallacy of ambiguity. They've never explicitly said what their assumptions are, yet they've implied many different assumptions. So anytime there is criticism, they can simply claim that this isn't what the theory says, or that the person is arguing from ignorance because they don't understand the math. The math, which gets the right numbers, and thus allegedly proves their irrational assumptions, which they had to try to use to interpret the math to begin with. Got it? The one criticizing is accused of straw manning and arguing from ignorance no matter what, even though the accuracy of their empirical equations has nothing whatsoever to do with the rationality or irrationality of their assumptions about reality. And their insistence on being vague to the point where these physicists themselves admit, right? They admit that no one understands what the hell the theory even says. They use the term, quote, theory to simultaneously refer to their alleged physical interpretations and also to their equations. Because the equations can successfully make very accurate predictions, that's always what they shove in your face. You dispute it, oh, but we can make really accurate predictions, so go away. Because the equations can successfully make very accurate predictions, they turn around and imply that their physical interpretations for those equations are somehow proven, or that there is strong evidence for them. And I keep going back to the warped space-time, but of course all those things I mentioned earlier are examples, right? Warped space-time. The impression is that the warped space-time, what warped space-time is, that's completely defined by the equation. Well, if that's the case, the equation contains variables which are quantitative measurable quantities that depend on observers and therefore can't say anything about existence, which is observer independent. It doesn't depend on your measurement process. Something is the way it is, independent of your interaction where you try to gain clues about it, right? So they use the term theory to, oh, look at our equation, it can get the accurate predictions. So on the prediction side of things, we get it right. We fail to falsify ourselves. And then somehow that's supposed to turn around and say, ah, that proves our physical interpretation. Warped space-time, right? Well, warped space-time isn't a physical interpretation. It's an abstract mathematical concept which does not exist. They can't tell you what it would mean for it to exist. All they can do is give you these, quote, lower dimensional analogies where it's the gravity well or gravitational waves or whatever, right? They give you these images, so they're illustrating shape, they're illustrating objects, but they're saying, psst, asterisks at the end of that. By the way, none of this shit actually exists. That's nothing like it really is in reality, but we can't tell you what it really is in reality. We can't tell you what our real assumptions are because, well, they don't have any. They don't have any explanations. It's all totally irrational, totally based on smoke and mirrors. Nonsense. In fact, any attempts at a qualitative physical interpretation for the evidence, including the equations, is purely made on assumptions that are made in an attempt to interpret, understand, and explain the equation. The equation or its accuracy has no bearing whatsoever on the assumptions, since it is the assumptions which are established outside of the equation and are used to interpret the equation. Warped space-time is an attempt at a physical interpretation. It warps, it expands, it bends. The Big Bang goes off, and this, what, the universe, quote, expands like a balloon, right? They even tape the balloon, right? You got the pennies, remember that? In school, you got the pennies with the balloon? Well, gee, a balloon's a fucking object, isn't it? It's got shape. Anybody understands a balloon? You expand the balloon, you blow the air to it, it expands. Great. And they're saying, okay, this is somehow kind of sort of what it's like for the universe to expand, only it's actually absolutely nothing like that. Because that's not literally what's happening, that's figuratively and poetically what's happening. Well then, you're talking about the galaxies moving away from each other like pennies on the balloon. What the fuck? We didn't explain anything. Expanding space? Time? Yeah, maybe in Alice's Wonderland. The assumptions are about what exists in reality. And this cannot possibly be specified by any mathematical equation in physics. The only real connection is maybe how well one thinks the assumptions and the theory explains the evidence. Oh, this is a great explanation for why the apple falls. But at best, that's really your scientific opinion. The primary consideration is whether the theory itself is even rational pursuant to the criteria I laid out earlier. Physicists refuse to admit that they are making assumptions about reality, while simultaneously implying that all their diverse assumptions are somehow facts because the math works. The assumptions they use to interpret the math. Physicists confuse mathematics and physics to the point where if some new evidence disputes the math, they might simply retroactively amend their physical interpretation to save the equation. Like, say, the galaxy rotation problem. Newton's law of gravitation, Einstein's field equations, general relativity have a little bit of a problem with that, maybe. So instead, let's sprinkle dark matter in all the areas it needs to be in order to make everything work out. Okay, well, I mean, kind of just throwing the whole empirical method out the trash can there, but okay. And this is a side criticism. So I want to be very clear about something here. When I criticize the mathematics, there's two tracks of criticism. One is just the criticisms of the physical side. They're irrational. That's easy to make. On the other side of things, there's a little bit of criticism to be had for the mathematics itself. Now, heretofore, I had stated that I have no problem with the mathematics, that it can make excellent predictions, which I still think it can, and that it's fine. But as a little side thing, I don't have to make this argument, but I think it's still worth pointing out, which is that the equations don't work. They either retroactively amend their assumptions, or they just mold the math, right, to match the observations, which really isn't a problem, but yeah, okay, then it's no wonder why the fucking equations work. The whole process of developing an equation is trial and error and fucking around in reality and making measurements and engaging in pattern recognition until you get to an equation where you keep going with it and keep going with it. And it's like, okay, now we got it. Now we got it. Now we're not finding new shit that's disrupting the equation. And if that does happen, well, we just, change it up a little bit. And if at the end of the day, all you want is mathematical equations to make predictions, then that's fine. Who cares? Change it as many times as you want. What does it matter? But don't turn around and say, look how accurate our equations are. Now we can say that our irrational physical interpretations are proven. What? No. Right, okay. By conflating empirical mathematics with physical assumptions about reality, physicists have effectively rendered their theories unfalsifiable, because they can either amend the math, calculate things differently, or amend their physical assumptions in order to account for any new observation. Now, the extent to which they really do that, in which it happens, is debatable, and certainly the equations they have come up with, like, even take Newton's law of gravitation, I think it works, right? It's awesome. It's useful. I think that's still what they use how to calculate rocket trajectories. But the more and more we get into modern physics, the more you get into, say, Einstein's field equations for general relativity, it starts to kind of get a little fuzzy, doesn't it? Let's say they always brag about the precession of Mercury. This problem's been around since the mid-19th century, at least, maybe before. Where, okay, we got the Mercury has a slightly elliptical orbit, and that elliptical orbit precesses every year, right? By a very small amount. And I can't remember the name of the guy that discovered this or who found this problem, but it's like, it looks like Newton's equations aren't accounting for this. Right? It was kind of like, ooh, this is something empirical which disputes Newton. So of course, then Einstein, who is well aware of this, goes in and tries to mold and toy around with the math of general relativity, more or less, from what I've seen. All right, there's different ways that it has been calculated, and is able to basically massage, if you will, the math in order to get it to fit that observation, and then turn around, aha, look, that's evidence now, because, see, I showed it with my equation. That doesn't really make sense. Again, side criticism. Right? Either way, the explanation is still irrational. Physicists routinely and vociferously. Oh, by the way, especially once we start getting into quantum mechanics, we talk about, you know, normalization and infinities, and you have the Large Hadron Collider, which spits out so much data. The Large Hadron Collider spits out so much data. First of all, it started in 1998, 10,000 scientists, 10 years, over 100 different countries, billions of dollars. It spits out so much data through the detector that they have to dump 99.99997% of it through this multi-tiered process with all these computers on site with millions of lines of code, algorithms written by the physicists themselves, and it's passed on down to these off-site places and all these other multi-tiered process, and they're processing and the algorithms and all this data and virtually getting rid of all the data and keeping this tiny little bit of what they think is interesting. It's like, hey, does anybody see a problem with that? Then you spent $13 billion of public money and you turn around and go, oh, we found a Higgs boson. Yeah, I'm sure you found a Higgs boson. Sure. Hey, you got to justify the bill, don't you? Oh, and they're breaking their champagne bottles open. It's a great discovery. Nobels for everybody, right? And you go, how does an apple fall? And they go, I don't know. Christ, why don't you work on the apple before building a Large Hadron Collider? Fuck. Right? And of course they'll say, oh, you know, it's within 5 sigma of all this super complicated math and blah, 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 blah. Well, a Higgs boson is an abstract mathematical concept. It's a zero-dimensional particle. It's a mathematical abstraction. It does not exist. I don't need to do an experiment to explain that. You just need to define what an object is and what existence means. And again, empiricists have a problem with this. Well, you can't just disprove it with an assumption, with a definition. You can't do that. You can't do that. Yeah, but you got to back up and remember that you're looking at an empirical experiment with a detector, with an empirical measurement, empirical data. And to say that the Higgs boson exists is an assumption used to try to explain that empirical data, and it's an irrational assumption. Higgs boson or the Higgs field, whichever one, right? A field, abstract mathematical concept, doesn't exist. Not real. So, right, and so physicists routinely and vociferously claim that their physical interpretations, they routinely and vociferously claim that physical interpretations, that's part of philosophy. If they were to watch my video, they'd say, no, he's engaging in philosophy, not science. This is unimportant. Oh, right? Philosophy, and so it's not important because the real science is the math, because that is what can be shown empirically with experiments, and we can do it repeatable experiments, and I do my experiment and you do yours, we get the same result, and nature's telling us what to do, right? That's what makes it objective. That's what's supposed to make it objective. And the current frame of thought of science, that's kind of how everybody thinks, isn't it? Every time I talk about this, where are your mathematical predictions? Where are your quantitative predictions? Predictions, bust out your crystal ball. Tell me what's going to happen. And great, yeah, it's useful for technology, but for fuck's sake, don't we want to explain anything at some point? Don't we want to understand some shit instead of some Alice in Wonderland wormhole bullshit? Fuck. Right. So they're always saying, oh, that's philosophy. We need empiricism to tell us how it is. Well, okay, but we just get right back to what the current version of the scientific method does, which it blends empiricism with assumptions and explanations. It blends these two and confuses them. Confuses math with reality. It confuses all these things. So that, yeah, you end up with equations that work and they're useful and so on and so forth. But then their assumptions, they are making assumptions. So if that's philosophy, well, they're engaging in philosophy by their own definition. But it's only, of course, their philosophy, which is proven. It's their interpretations, their assumptions for the equations, which are allegedly proven, and we all have to accept, and they get to shove that down everybody's throat and say, give me another couple billion for another collider, well, don't you? Right? So, right, simultaneously proclaim that their physical interpretations are facts and that they're essentially proven because their equation got the numbers right. Right? They refuse to admit that these are simply assumptions about reality, and they strongly maintain that any rationality-based criticisms of their irrational assumptions are merely philosophy or word games. They're just redefining reality through philosophic word game, word gesturing, and somehow you're acting as if that disproves things. Let me tell you something, mister. We have to adjust the atomic clocks on GPS satellites, right? Sometimes stars look like they're orbiting nothing and material is being ripped off of them and being sucked into nothing. What's that? That's what we see. Or why is there such energetic phenomenon? Jets and everything else shooting out of the center of a galaxy. Got to be a supermassive black hole, right? These things are all evidence. We see the energetic phenomena, quote unquote energetic, right? The star with material getting ripped off looks like it's orbiting nothing. We got, yes, they do have to adjust atomic clocks and GPS satellites. That's not what's being disputed. The evidence isn't being disputed. The predicted power of the equations isn't being disputed. It's your interpretations and your assumptions which you are attempting to use to understand and explain that evidence. That is the problem. You don't use evidence to prove assumptions which you use to interpret the evidence. That's circular. Right? So, it is the physicists, right? It's they, the mathematicians, who are the prime word jesters, the word gamers. They're the ones playing word games because they utterly refuse to provide scientific definitions for their key terms. They're the ones using their key terms to mean different things throughout their presentation. They're leaving it up to their audience to decide what those key terms mean. They're refusing to define their terms. They're using their terms inconsistently. So who's playing word games? Right? They're accusing you of playing word games. They're the one playing fucking word games. Shit. And they insist on routinely using their key terms with massive and obvious inconsistency. And they deflect any criticisms by simply proclaiming that their equations work, even though this has nothing whatsoever to do with their assumptions about reality. Because rational understanding has been sacrificed at the altar of truth, because rational understanding has been sacrificed in lieu of ability to empirically predict rather than explain, physicists have missed the entire point of science. They should be praise you for getting those equations. That is amazing. It's an amazing accomplishment. All the evidence they've been gathering all these years, super useful. Excellent set of clues. Gives us a broad scope of clues to work with. Thank you for that. Very admirable. Very awesome. Right? Equations. Great. Thank you. The technology. Trust me, I love you for the technology. Computers, the internet. What would I do without the internet? I don't know. Right? So that's all great. But let's not get crazy. Let's not turn that into a religion. And if you're talking irrationally, then you kind of miss the science boat, I think, a little bit. Mathematical prediction is great for engineering and technology, and it works. But on the explanation side, they've descended into total irrationality because they've failed to make basic first-grade level distinctions between mathematics and physics, explanation and prediction, theory and evidence. So, here's a couple actual quotes, at least according to the internet, from some well-known physicists. These are the kind of shit that they're saying, okay? Should be sending off alarm bells in your head. If they haven't already been firing off already, 5 minutes after watching any documentary on physics, and they're already blathering about warped space-time and quantum mechanics. Right? Zero-dimensional particles. Okay, so, quote, "We are all agreed that your theory is crazy. The question which divides us is whether it is crazy enough to have a chance of being correct. My own feeling is that it is not crazy enough." So I got two things there. He's saying your theory isn't crazy enough. In other words, it makes too much sense. It's got to be more irrational. nonsensical, incoherent. It's a little too rational for Niels Bohr's taste. Let's crazy it up a little bit, shall we? Right? And his question, of course, is what divides us is whether it's crazy enough to have a chance of being correct, true. What's he doing inserting the concept of truth in there? If an explanation is just about understanding a possibility, then at one point do you go and say, oh, it's true, it's correct. Why? Because the math made the right prediction? How do you prove something using empiricism about assumptions about reality, which you use to interpret that empiricism? Correct. This obsession with correct. Who else does that? Obsession with truth. Religion. You go to church, they don't define object. They don't define existence scientifically, but they talk about the truth. Everybody's got the truth. Nobody can define the word truth. Nobody can define the word object or existence. Oh, damn sure we've proven the truth. So give us another couple billion for another collider. What am I... Okay, here's another quote. What am I going to tell you about... Sorry, what I am going to tell you about is what we teach our physics students in the 3rd or 4th year of graduate school. It is my task to convince you not to turn away because you don't understand it. In other words, convince. Where's that word come from? Convince. You ever convinced somebody of something? That's not where you approach them and say, well, here's the reasons I think, and I'll just let you hear that, and you can kind of come to your own thing. And I know, convince is, I want to get you on my side, right? I want to wow you with mathematical equations or with experiments like the double slit experiment. Ooh, we don't have an explanation for it. Nature must be mysterious, right? To convince you, to wow you, to tingle your senses with fanciful sci-fi stories. My task to convince you not to turn away because you don't understand it. In other words, if you don't understand it, if you got alarm bells firing off going, it sounds like religion, this doesn't make a fucking bit of sense. My task to convince you not to turn away. You see, my physics students don't understand it. That is because I don't understand it. Nobody does. Then what the fuck are they talking? What's anybody talking about? If you don't understand it, then what have we explained? Okay, that's Richard Feynman. Here's Werner Heisenberg. The uncertainty principle. Physicists have come to realize that mathematics, when used with sufficient care, is... Oh, Christ, I got the wrong one. Sorry, this is Werner Heisenberg. Not only is the universe stranger than we think, it is stranger than we can think. Right? Getting to this idea that nature cannot be understood by our puny primate brains. This one's Brian Greene. You may remember him from such films as, Horseshit, Quantum Mechanics, and other bullshit. Okay, so now he's got some fun ones, string theory, all that stuff. Brian Greene, Elegant Universe. I don't know if this is from Elegant Universe, but this is him. Okay, so physicists have come to realize that mathematics, when used with sufficient care, is a proven pathway to truth. Holy shit. That's not religion, right? The whole idea is that because we can't understand nature, we can't understand reality with our stupid primate brains, what mathematics does, all these crazy symbols, right? You're scribbling up on the board and you're pulling your hair out, right? And you see something that makes sense in the numbers. You see the voice, you hear the voice of God, or maybe you see the combination of numbers that is the name of God. Maybe not that extreme, but the whole idea is that through the math, even though we can't understand in a physical, more normal sense, right? The complex math and the higher dimensions and the warp speed, all this complex mathematics that is highly abstract, somehow allegedly gives the ability to basically understand things that cannot possibly be understood, because they don't make any sense, because they don't refer to anything. Right? It's like this, they've created this massive complication that has presented itself as being, quote, realistic because it is capable of making predictions, right? Through empiricism, through measurement, right, you can sort of latch the mathematics on to your experiment, to reality, in a way that you can specify this pattern recognition, patterns, observed patterns, right? And so this math, well, it almost takes on a life of its own, like it has its own reality, to the point where physicists get into the mode where they're taking their abstract mathematical concepts and thinking they're real. That's irrational. The proven truth. Christ. It is often stated that all of the theories proposed in this century, this is another guy, by the way, quote, it is often stated that of all the theories proposed in this century, the silliest is quantum mechanics. In fact, some say that the only thing that quantum theory has going for it is that it is unquestionably correct. That's Michio Kaku. Unquestionably correct. The unquestionably correct proven truth. Sounds a lot like church, just saying. Unquestionably correct, really. Well, what do they always say about quantum mechanics? Quantum mechanics is the most well-tested theory in all of science, and it has never gotten a prediction wrong. The standard model has never gotten a prediction wrong, and every single prediction it's ever made has always been empirically verified, or at least failed to be falsified. Every prediction it's ever made has gotten absolutely 100% correct. Okay, fine, let's grant all of that, even though I think it's still horseshit, because you're molding the mathematics to fit whatever, fine, let's grant that. Let's say yes. Every prediction you've ever made, your math is freaking as perfect as it can be. So what? Math doesn't say anything directly about objects or existence, and your physical interpretations for quantum mechanics are what the problems are. That's where the problems lie. Because there is, oh, I already read that one. That's Stephen Hawking. Okay. So, this is the kind of stuff being tossed around. Right? It's supposed to be a little bit tongue-in-cheek. Feynman says, well, nobody understands quantum mechanics. Everybody goes, ah! But really, somebody understands it, right? No. They don't. That's the big secret. Nobody fucking understands it. Because it doesn't make any sense. It's not possible to understand. Right? Physicists are, at least modern physicists, are modern-day mystics. They revel in what they do not understand. They revel in the mystery. You all see it when the physicist is talking about the cosmos. And his eyes glaze over and he's like, oh, warp space time! Time travel! Right? They revel in what they do not understand. The mystery. And it's this which captures the imagination of the masses and lovers of sci-fi, science fiction, who basically have found physics as a way to retain magic and mystery about the world. Their entire approach defies what science is all about at its core, which is visualizing physical explanations in order to understand and demystify nature. The entire point of science is demystification, not mystification. They're going in the wrong direction. It is the mystics who are revolted by rational understanding. They want the emotional awe of ignorance. The bottom line, and here's the bottom line. Every time I say things like warp space-time is inconceivable, has no physical meaning, it's an abstract mathematical concept, does not exist, and it doesn't explain anything, therefore. Same with zero-dimensional particles, fields, higher dimensions. I am told that just because our puny primate brains can't understand it doesn't mean it's not true. Here's another quick example. This is from the book The Quantum Universe and Why Anything That Can Happen Does, by physicist Brian Cox, he's the British guy, I believe, and I think his name is Jeff Forshaw. Yeah. Okay. So a quote from their book, from chapter 7, I guess it is, The Universe and a Pinhead and Why We Don't Fall Through the Floor. That we do not fall through the floor is something of a mystery. To say the floor is, quote, solid is not very helpful, not least because Rutherford discovered that atoms are almost entirely empty space. That's not really the point of me reading this, but they always How many times have you heard that regurgitated? Did you know that atoms are almost completely empty space? Really? So Rutherford did an experiment with gold foil, empirical experiment, and with somebody's interpretation that atoms are mostly empty space. That is an assumption used to interpret and attempt to explain what was seen empirically. That does not automatically mean that it is the only possible explanation for what was observed in that experiment or any other experiment. But yet they just state it like it's a fact. They just state all these things like they're facts. Did you know atoms are almost made of entirely empty space? No, I didn't know that. The situation is made even more puzzling because, as far as we can tell, the fundamental particles of nature are of no size at all. Dealing with particles, quote, of no size sounds problematic and perhaps impossible. Yeah, sure does. Right? But nothing we said in the previous chapters presupposed or required that particles have any physical extent. The notion of truly point-like objects need not be wrong, even if it flies in the face of common sense, if indeed the reader has any common sense left at this stage in a book on quantum theory. So they're saying it has no size. Now when I say a zero-dimensional particle means it has no size or shape, what the proponent of physics says is, no, that's a straw man. You're straw manning, right? Okay. Well, it's a simple matter, right? The fucking thing either has shape or it fucking doesn't. And if it does, then illustrate it. And if you're not illustrating it, it's because you can't. It's because you don't have an object. It's totally simple. There's no way to hide behind any bullshit with this. Right? Does it have shape or doesn't it? Yes or no question. Black or white question. Right? Well, to me, I'm interpreting, because they leave it up to us to interpret, I'm interpreting these words to mean that it doesn't have shape, because they are saying the fundamental particles of nature are of no size at all. By the way, fundamental particles, I believe there's about 17 of them. Very elegant. Of course, they've never gotten a prediction wrong. They have this zoo of different particles, which of course they've proven with their experiments, even though they have no size, no shape. Dealing with particles of no size sounds problematic and perhaps impossible. Oh, if it doesn't have shape, it doesn't exist. It's inconceivable. If you don't have objects of your hypothesis, then what is doing anything in the theory stage? What's doing anything dynamically? What am I imagining? What am I understanding? There's no basis for the explanation. But nothing we said in the previous chapters presupposed or required that particles have any physical extent. So they don't exist. Okay, great. The notion of truly point-like objects need not be wrong. Right? Always going back to this concept of truth or verification or wrong or correct or right or wrong, right? Because that's how you convince someone with shit like that. Convince you that it's right or convince you that it's wrong, rather than rationally justifying their hypothesis. They skip over that whole part. The notion of truly point-like object. Well, if it's truly, quote, point-like, depending on what you mean by that, or if you're saying it has no size, well, really size is a relative concept. Something is only big or small relative to something else. But they said no physical extent. That to me means no shape. So it's not an object. The notion of truly point-like object. It's not an object because it doesn't have physical extent. Therefore, by definition, it is not an object. To say that you have an object without physical extent is a contradiction. It's contradictory. And so, yeah, of course it flies in the face of common sense. That's why it doesn't make any fucking sense. So, right, we have all these things that don't make sense. But hey, what's the problem? This all relies on the fallacious notion that mathematics says anything whatsoever about objects or reality, and that math is somehow this window into some kind of understanding which defies basic visualization, that the language of mathematics is how we transcend our puny imaginations and discover the truth. This is nothing more than pseudoscientific, new age religious horseshit, right? You've seen the video where they're like, the 10th dimension, we're going to help you intuitively Imagine the 10th dimension, and you watch it, and it's just all I see are fucking shapes, right? Two-dimensional representations of shapes on the screen. Right? I don't. What do you mean 10th dimension? Because it doesn't mean anything. Well, the language of mathematics is the language of empiricism, the language of measurement, quantification, of interaction, and it needs to be interpreted because it says nothing about objects or existence directly. Observers, whereas existence is observer independent. Quantum mechanics, in particular, also likes to say that we evolved here in Middle Earth, right? We evolved at the macroscopic scale, so there's no reason to think that our brains, which evolved at the macroscopic scale to deal with macroscopic objects, would have any ability to comprehend or understand the super duper 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 tiny. But a tiny little quantum scale is so fast and fuzzy, right? It's fuzzy, and it's you even hear them say fuzzy. It's blurry. It's fuzzy. Well, your thinking is blurry and fuzzy, and irrational. But that's what they're saying. Hey, why should our brain place a limitation on what's possible in nature? Okay, that's fine. I'm fine with that. I'm not saying that our puny primate brains and the happenstance circumstances of our evolution, because it is macroscopic, places any limitations on nature, or can stipulate in nature what is or isn't, happening at the very small scales. However, while our brains don't place a limitation on nature, our ability to understand does place a limitation on our ability to understand things. Right? That's where the limitation is, if you want to call it that. Right? And here's the core issue. Okay? If it really is the case that we cannot understand nature, then how would it help relieve our ignorance to try to fill that void with theories which we also cannot understand? If the assumptions, like zero-dimensional particles or whatever, are irrational, right? They don't have any physical meaning to us, then how does it help with our ignorance problem? If nature is such a way we can't understand it, how does it help to understand it with theories that we can't understand? We have no choice but to place rational requirements on explanations in order to distinguish them from religion and to ensure that they actually enlighten us with understanding of a possible explanation. The placing of rationality requirements on the process of proposing explanations for consummated events is known as science. And the formal series of steps required to do this is called the scientific method. If physicists are claiming that we cannot rationally understand nature, then they are not doing science, they are doing religion. They are claiming that the truth of their religion is essentially, quote, proven, or they have strong evidence for it empirically, and when challenged, they hide behind the complex mathematics in order to wow and intimidate everyone and delude the human race, themselves included, that any of their equations have anything to do whatsoever with assumptions and explanations. The assumptions and explanations interpret and make sense out of the equation and explain the pattern that is encoded into the equation. So what they're really saying is that they haven't thought of a way to rationally explain gravity, light, electricity, and magnetism, and all the other phenomena that they have dutifully documented over the past 350 years. And meticulously documented. Thank them for that. That's great. That's awesome. Glad we had that. Super helpful. Huge broad scope of clues to look at. The more clues we have, maybe we can think of a set of assumptions that will suddenly make all this shit click, make sense out of it. They're saying, no, that's not possible. They're thinking in terms of particles, zero-dimensional particles, or at least acting like they are, right? All these other abstract mathematical concepts and saying, oh, we can't explain the double slit experiment. We can't explain all these other stuff. We can't explain, oh, it's irrational. It's not, excuse me, they don't say it's irrational. They say that we can't really understand it because we don't have the ability to. But we have no choice. We have no choice but to take a rational approach. That's the whole point of science. That's what science is. Okay? Let's try to understand nature rationally. That's what science is. all of relativity and quantum mechanics, while the equations work, from an explanation perspective, they can be summarized as nothing more than physicists completely giving up on anything remotely resembling a rational explanation for anything. It can build a multi-billion-dollar Large Hadron Collider and pour over super complex mathematics, yet they can't explain the simplest of phenomena, like why the damn apple falls towards the earth. So they poo-poo so-called classical physics. You hear many lecturers say this at the beginning of their lecture. Okay, you're not really going to understand anything I say, so if you ask annoying questions, okay, they don't phrase it like that. I'm just going to sort of, pile drive through your question and kind of paper over it and give you some kind of explanation, quote unquote, that they say, oh, we can't do the classical depiction, which in a way is supposed to kind of, in a vague sense, mean that they're talking about, being able to imagine things like objects and so on. Right? And when I talk about objects, people go, oh, you're just talking about classical physics, man. You're living in the past. We've evolved beyond that. We have Alice in Wonderland horseshit now. Right? We don't do this classical physics stuff, right? Understanding things, trying to discover explanations. But the rational scientific method is not classical physics. Folks like Newton, for example, never scientifically defined their key terms. He didn't define object and existence scientifically. And if he did, I don't know where he did. So the rational scientific method is not a resurgence of an old way of thinking. It's not classical physics. It is the discovery of rationality and the discovery that defining existence scientifically, what that does is obliterate every religion known to man. And keep in mind that it's just an assumption. Hey, this is a definition of existence. The objectively distinguishing criterion of this, or distinction of this definition of object and existence, these definitions, is that they can be used consistently in a scientific dissertation. We can break out of circularity, and we can talk about understanding things visually, use spatial reasoning, in order to demystify reality and all these things that don't immediately seem like they make any sense. Why does it fall towards the earth? Things like that. Why do magnets attract? Seeming magic tricks. By seeing the unseen with the mind's eye through imagination, by making assumptions, which can be used consistently, which can be visualized, we can visualize and understand the unseen mechanisms through which we can explain rationally what we're seeing. And I think the result that comes out of that is pretty breathtaking. So in future videos, I'll probably talk more about that. Sorry if I'm a little harsh on the physicists. I do want to reiterate that I'm not trying to completely break down or take away from what physicists, their life work and their accomplishments. I think what they have done is very important, laying the groundwork of all the documentation of evidence, the clues, the equations, the patterns. It's all extremely important, and it's wonderful for developing technology and for engineering and all these things. So these are wonderful accomplishments, and they should be praised. But it just needs to be placed in its proper context. Let's not convert it into a religion and act like just because Stephen Hawking says something all the fucking sudden, all right, we got to let go of our own ability to reason and entertain this total nonsense. Okay, I think I went on really long, and that was what I was trying to avoid. But sorry, I can't help it. It's kind of the nature of the discussion. So, yep, hour 20 again. Nope, it's hour 19. I cut off 30 seconds, so I saved you 30 seconds. Till next time.